In this learning goal video, we're going to talk about how to anticipate the impact of changing the sample size on the strength of evidence. We'll use the Confident Faces data to discuss this learning goal. In the Confident Faces data, 32 Senate races were predicted. But what if instead of 32, it was actually 64, or 128? What happens to the strength of evidence as the sample size increases? Well, here you can see dot plots showing you the results of 1,000 simulations with three different sample sizes, 32, 64, and 128. The difference between these different null distributions is that as the sample size increases, the variability of the null distribution decreases. Here's another way to think about it. These are all approximately bell-shaped curves. If you think about a bell-shaped curve as a tablecloth that you've lifted up in the middle of the table, then as you increase the sample size, it's like pulling the tablecloth up in the air, higher and higher. What happens as you pull that tablecloth up higher and higher from the middle of the table? The sides pull in and the top moves up. So as you increase the sample size, you're pulling the sides of your distribution in, just like you're pulling the sides of the tablecloth in as you raise the center of the tablecloth from the middle of the table. So as you increase the sample size, it's like pulling that tablecloth up toward the middle, the sides pull in, there's less variability in your null distribution. You can see this also by looking at the standard deviation of the null distributions. When the sample size is 32, the standard deviation is about 0.088. At 64, the standard deviation is 0.04, and at 128, the standard deviation is 0.031. So what's the impact on strength of evidence? Well, the same proportion looks more extreme for larger sample sizes. For example, if 71.9% of elections are correctly predicted with a sample size of 32, that's the real data, your p-value is about 0.009. But if the sample size was 64 and that same 71.9% of elections were correctly predicted, the standardized statistic z would be 5.09. The p-value would be less than 0.001. And if the sample size was 128, that standardized statistic would go all the way up to 7. The take-home message is this: as the sample size increases and the value of the observed statistic stays the same, the strength of evidence against the null hypothesis increases.